Hey guys, in this video, you're going to become an expert at protecting your users' private keys, which means we're going to be covering 3 potential security issues that you might have in your code right now. From there, we'll quickly cover the solutions, and to help connect all the dots, I actually went ahead and built this app for you guys so that you guys can see these security best practices in action. And to help make your life easier, I'm giving away all the source code completely for free so that you guys can just start copying and pasting these solutions into your own projects. So enough chit chat, let's go ahead and dive in and start securing your apps right now. So to help us better understand the 3 common vulnerabilities that might be happening in your code right now, let's pretend that you just built an app that generates funny dad jokes by connecting to OpenAI. All we need is for our users to give us their OpenAI keys, and then we handle the rest. So now that you have some background, let's go ahead and break apart this app into its core components and uncover just how vulnerable it really is. For scenario 1, we're going to pretend that we're saving our users' super secret OpenAI keys to our backend database. Well, here are the 2 problems with this approach. First, you and I could accidentally make a mistake. For example, we could forget to add our .env file to our git ignore list, which would mean we've accidentally leaked all of our environment variables out to the internet through our GitHub account. So anyone who has access to GitHub could go in there, swipe our environment variables, and just grab all of the data from our database. And because everything's in plain text, they could just swipe it. Now that's with you and I making a mistake. The second thing is the database provider themselves could have a leak. And in that case, once again, anyone who is malicious could go through the database and actually swipe all of our users' OpenAI keys and do whatever they would want with them because they're in plain text, so anyone could grab them. So saving the keys in our backend database in plain text is a no-go. So let's move on to scenario 2. So for scenario 2, we're moving away from the backend database because that's scary now, and we're just going to save our users' super secret OpenAI keys to the local storage in our front end. This should be safe, right? Because, everything's just on the client and nothing should be able to access these super secret keys. Well, that's not entirely true. Here are 2 scenarios where this could actually come to bite you. First, if the user has a rogue Chrome extension installed or it gets compromised, that Chrome extension can actually scrape all of your different local storage keys and actually find your user's OpenAI keys. I know I said key a bunch, but once the Chrome extension has access to these secret information, they could go off and start charging your client and rack up a huge bill for them. The other scenario is if the user goes to some sort of site that they're not supposed to and gets a small virus. Once again, that virus or malicious code could scrape the local storage and actually grab your OpenAI keys that you're saving on your user's behalf. So once again, the front end saving your plain text keys in local storage is also not safe. So let's go ahead and talk about scenario number 3. So now that we're in scenario 3, we're starting to learn that the front end local storage isn't the problem and the back end database isn't the problem. The root problem is the fact that we're saving our users' OpenAI keys in plain text. So now we decide to get smarter and start storing our users' OpenAI keys after we've encrypted them. So to do this, what we do is we make a new encryption key that we save in our front end code. And let's just say its encryption key is equal to 123. Well, now we encrypt every OpenAI key as it comes in. Once it's encrypted, we save it off to our backend database. Now, whenever something goes wrong in the future, and let's say there's an accidental leak in our database, well, the malicious users will not be able to access our users' OpenAI keys because all they're getting is encrypted mumbo jumbo on the back end. But we're still not out of the clear. And the reason why is because these malicious users still have access to our encryption key. And the reason why is because we have decided to encrypt our users' OpenAI keys on the front end, which means the encryption key itself is exposed. So anyone who parses through our front end code can grab that encryption key and they're able to decrypt all the information inside of our database. So once again, we're back at the same problem where bad people have our users' OpenAI keys and can start racking up a bill. So now that we've covered how everything can go wrong, let's go ahead and move on to the solution, which is the most safe and most practical way to start saving and encrypting your users' OpenAI keys. So now that we've covered the 3 different scenarios and gone through all the problems with them, what we're going to do is cover the solution now and walk you guys through how this works in 6 simple steps. And then we're going to talk about how this is the most safe option. So for step number 1 for our solution, what we're going to do is accept our users' inputs. So we're going to be able to access their OpenAI keys. And then it's up to us to start encrypting them. But this time what we're going to do for step 2 is we're randomly going to generate our encryption keys on the front end. We're not going to hard code them. We're going to randomly generate them. From there, in step number 3, we are going to encrypt our users' OpenAI keys. And what we're going to do with these encrypted OpenAI keys is first, in step number 4, is we are going to save the encrypted keys to local storage so we can access them later. In step 5, we're going to save those randomly generated encryption keys off to our backend. From there, whenever we want to decrypt the user's OpenAI keys and make a request to OpenAI, all we have to do is just fetch our encryption keys from our backend database, pass in our encrypted OpenAI keys on the front end, and then just send a request through HTTPS over to our backend to make a call over to OpenAI. And this is going to be secure because we're using HTTPS to send over our decrypted OpenAI key. So everything's going to be secure from end to end. So that's how it works in 6 simple steps. And we're obviously going to, in a few minutes, code the solution up so that you guys can see these steps in action. And outside of that, I just want to cover why this option is so much more safe than everything else that we've done. Well, in this option, what we're doing is if the user downloads a rogue Chrome plugin for whatever reason, and that Chrome plugin scrapes all of the different local storage variables and gets access to the OpenAI key, well, it actually doesn't matter because that OpenAI key is going to be encrypted. So check on the front end. Well, let's look at the back end. If for whatever reason we accidentally, save our environment variables to a public folder, or if some malicious user gets access to our database, once again, all they're going to have access to is going to be the randomly generated encryption keys, and they can't do anything with that. The only way someone can get access and really mess with our users' OpenAI keys is if they are able to hack or maliciously take advantage and exploit the user's front end to where they can scrape the local storage key. And then second, they also need to be able to steal data from our database. So we're protecting our data in 2 different places, which means we do not have a single point of failure. So this solution is infinitely more secure than what we've been doing previously. And enough talking about this solution, let's actually hop over to the code now and start coding this up. Oh, wait, real quick. I just want to mention 2 things. First, to grab the source code for this project, all you have to do is just scroll down in the description and there'll be a link to where you can grab the source code for this video and all of my other full stack AI projects. And it would mean the world to me while you're scrolling down if you could hit that like and subscribe button. Second, if you need any help with this project for whatever reason, feel free to drop a comment down below, or you can actually click the link in the description, which will help you book a one-on-one call with me where we can go over whatever problems you're having and we'll try and get to the bottom of it. But enough of that, let's get back to the video. So now we're diving into the fun stuff where we're actually going to start coding up and implementing these 6 steps that we just talked about a second ago to start securing your users' OpenAI keys. And before we do that, I do want to mention, just as a high-level overview, the application that we're about to run through. At a high level, this is a Next.js application that we're going to be using TypeScript for. And this Next.js application does have some back-end logic, which we'll touch on in just a second. But outside of that, it is connected up to a database like you saw on our example diagrams beforehand. And we'll also have this application hooked up to authentication. We're using Clerk. And the reason why is because as we generate those random encryption keys, we need to know which user those encryption keys belong to. So we're going to have to tie those together in our backend database. Now, if any of this seems overwhelming or you want some more guidance on this, once again, feel free to go grab the source code and the link below. But also, you definitely are going to want to check out 2 of my previous videos that I've done where I create an entire full stack application from scratch so that you guys can actually build something like this yourselves completely from scratch. One of those is going to be an AI fitness coach and the other one is going to be an AI lead magnet. Both great videos. I recommend you definitely check out after this. All right, enough talking. Let's go ahead and dive into step number 1 where we're going to start asking and accepting our users' OpenAI keys. So like I just mentioned, the first thing that we're going to work on is accepting our users' OpenAI keys that they need to type into right here. And what you'll notice is I've actually went ahead and cleared out our database and all of our local storage so that we're working from scratch. And we're going to work our way all the way up to generating our AI generated dad jokes. But the first thing that we're focusing on right now is accepting our users' inputs right here. So here's how we do that in our Next.js application. Well, the first thing is we need somewhere inside of our application to store the state of this input field. Well, how do we do that? We do it right here. We create a new use state where we're going to store an OpenAI key, and this OpenAI key is going to be a string. Well, how do we update it? Well, if you actually scroll down to later in the file, you'll see that we've set up our HTML code so that we have this right here, where you can see we have our OpenAI key, we have a label to the left, and now we have our input. The purpose of this input is to be an input of type password so that as the user types, it shows up as the dots, so we're not just revealing it to the world. And the other thing is as the user types in their password or OpenAI key, we are actually updating it in real time using this set OpenAI key function in real time. So that's how we're going to do step 1. Now let's actually move on to step 2, where we're going to be randomly generating our encryption keys. Well, to do this, what we need to do is scroll back up to the top of our code, and we need to talk about 2 things first at a very high level. So the first thing you realize when it comes to an encryption key is we actually don't have an encryption key over here on the right side of our application. We actually have a passphrase and a salt. Now, what the heck are these? Well, this leads us to point number 2. We are actually using a combination of a passphrase and a salt to generate our encryption key. And the best way to demonstrate this is to actually go over to our generate passphrase and generate salt functions in our cryptos utils file that we also have inside of this project. So let me walk you through the passphrase, and then I'll walk you through the salt and explain what they're doing, and hopefully this will help you tie together and prepare you for step number 3, where we're actually going to encrypt the OpenAI key that we just typed in. So the first thing is we need a passphrase. This is basically going to be the encryption key. However, what we're going to do is actually just randomly generate it. But there is an option, and this is why I wanted to show this to you guys with Salt, is we could have allowed our user to actually type in a passphrase here. They could have typed in super secret password. But just for application, we're just trying to make this as seamless as possible. So we're auto generating a passphrase for them. However, if we had allowed our users to type in a passphrase, what you want to do is add salt to it. Now, this might be a funny term if you've never heard it before, but basically what salt does is it helps people who commonly use the same passwords. Like, let's just say an example password that someone might use is just like, someone's older, they might just do like, yep, that's my password. Well, that's very bad practice. And what you want to do is actually just add some salt to the end of it. And salt is basically just random keys that get added to the end of a passphrase to help make it basically extra unique. And I think this is, like I said, this is probably one of the best examples I've seen out there. That best definition that explains it. It's just making the password hash output unique. So for example, if we were to, hash 1, 2, 3, 4, 5, 6, 7, 8 with common hashing functions, you would always get the same output, and it would be very easy for a experienced hacker or someone else to basically reverse engineer like, oh yeah, that's this password. But by adding some extra random keys at the end of this password that are going to be 16 characters long, that hash is going to be very unique, and that's going to prevent hackers from being able to reverse and basically look up very common passwords. So what we're going to do is we're going to generate the passphrase and generate the salt just to get you guys some more experience using common cryptography practices. So that's what we're going to do. We're going to call these 2 functions, generate passphrase and generate salt, whenever the user clicks generate salt and passphrase. And just to show you that in here, what we're going to do is if we scroll down, you'll see that we have a function called generate random credentials. And that's exactly what we're doing. We're generating a new passphrase, 16 characters long. Then we're generating a new salt. And what we're going to do is save the salt and passphrase and update the state, which we're saving right here. So I'm gonna go ahead and click it so you guys can see it update in real time. So when I click it, fantastic. We now have the passphrase and now have the salt inside of our application. And you'll also notice whenever I clicked it, it also enabled this encrypt button. And that's just because the way I've set up the app is as we have continually implement more and more of the key ingredients necessary to create an encrypted key or decrypted key, we're slowly going to give our app more functionality. So let's go ahead and move on to step number 3, where we're actually going to start encrypting our OpenAI key using the new encryption keys we just created. So now that we're on step 3, where we're actually going to encrypt our OpenAI key, I think the best way to go about this is to actually look at this from a high level overview first, and then dive down deep into the actual implementation. So I think the best way to do this is let's actually go down to the handle encrypt function that gets triggered whenever we click this button and look at the code. Well, the first thing you'll notice is we're going to call a encrypt key function. Once again, this is going to come from our utils package that we've defined, and we'll dive into this when we go into the detailed explanation. But the important part is this is going to return an encrypted key, or basically the encrypted data that's going to then show up over here on our application on the right. So this is the encrypted data that we're also going to want to eventually save to our local storage. So that's at the high level. We're encrypting our OpenAI key. Now let's actually dive into this encrypt key function so that you guys can actually see what's going on behind the scenes. Now, before we look, I do want to mention that this is a little bit complicated. Don't worry, you don't have to understand how it works. You just need to know that you need to use it is the important part. And feel free to talk to ChatGPT to dive into a super detailed explanation of how this all works if you want to go down the rabbit hole of encryption and cryptography. So let's go ahead and dive in. So what you'll see in our backend cryptos util library function is we're going to take in three things. The first is going to be the key, which is our OpenAI key. The next is the passphrase. And then finally, we're going to take in the salt. So what we're going to do from here, we're going to go through this step by step. And before we do this, I do want to show you what's actually going on behind the scenes. So what we're trying to do is take in our plain text, which is our OpenAI key. Then we're going to take in our secret key or our OpenAI key. Then we're going to pass in an initialization vector, which we're going to talk about in a second. Then we're going to pass all of that in into this encryption algorithm, and that's going to generate everything that we need to have our encrypted key. So here's how this works. I'm going to keep this up because this is very important. So the first thing we're going to do is we're not just going to encrypt our plain text key once. We're going to do it 10,000 times or some arbitrary number of times, because the more times it gets encrypted, that's another layer of security to basically make sure that you end up with something that's very unique, so that's not easily to reverse engineer. From there, what we're going to do is create the key size. So this is basically what's going to get, this will make more sense in a second, but this is the key, our encryption key size. And then from there, we're going to have our IV size. And IV stands for initialization vector. Basically, all initialization vector does, it's basically just an arbitrary number that can be used with a non-secret key for encryption to foil cyber attacks. Basically, the long story short, the more randomness, the more iterations that you can do when encrypting keys, the better. We're just trying to protect our users here. So I'm not going to walk through everything that's happening here, but I will just mention that we're using the Node Forge library to use our passphrase, our salt, and iterate everything 10,000 times to generate everything that we need to have our encryption key and our initialization vector. So that's all you need. We just generating the initialization vector and our new secret key. That's what we're doing right here. And then once we've done that, what we're going to do, once we've defined them, what we're going to do next is use the AES. Basically, this is our encryption algorithm on our derived key. So that's going to be our encryption key to start our cipher. And once we've done that, what we're going to get out of this is going to be our encrypted key. This is basically going to be the encrypted version of our OpenAI key that's going to come over here. So I know that's a lot. Please feel free to dive through this. I would definitely talk to ChatGPT to dive deeper into exactly what's going on here, but I don't want to turn this into a multi-hour tutorial. The important part here is we are mixing everything up here so far, generating a new encryption key, and we're going to start saving that in the next step. So let's go ahead and start actually clicking these buttons and actually seeing how everything works. And I'm going to go ahead and expand this so we can see what's going to happen, because eventually we're going to have a save option to store everything locally and to our backend. So I'm going to encrypt. And what we expect next is to show off our new encrypted key. So that looks great. And now what we can do is go ahead and move on to step 4, where we're going to start saving everything that we've generated so far, our passphrase and salt to the backend, and then save off our encryption key to our local storage. So let's go ahead and start working on that now. So I went ahead and actually split the screens, because now we're actually going to be diving deep into the save functionality, and there's just going to be a lot of code. So I want to make sure everything's big so you guys can see exactly what's going on. So let's talk about this. Whenever we save, we want to save our salt and passphrase to our database, and we want to save our encrypted key to local storage. So let's actually see what happens when we head back over to our front end code, how we actually do this. So the first thing is we're going to go down to the handle save function, and this gets triggered once again whenever we click that save button. This is the on click event handler. So let's walk through this. The first thing we're doing is we are going to set saving state so that whenever the user clicks the button, we can actually update the UI. So this will turn from save to saving. And then whenever it's done, it'll go back to save. So that's just some nice UI. But what we're going to do from there is we are going to make a request to our backend database or our backend endpoint, which is going to be a API user encryption. So we're going to hop over here in a second, but the important part to realize is all we're doing is we are making a post request. So that's going to push our salt and passphrase off to this backend endpoint. And then from there, the goal is to obviously save this data over to our database. So let's go ahead and hop over there right now. So we're going to go to API, and then we said user encryption. So here's what's happening at this endpoint. And once again, we're using Next.js 14. So we're going to be using the app router functionality where we actually will just define the post request endpoint right here. So what we're going to be doing is first off, we're going to check to see if the user is authenticated. Now this is going to happen because we're using Clerk, and I'm not going to dive too deep into this, but just know we're using Clerk to authenticate our user. So whenever an authenticated user makes a request to our backend, we'll actually be able to see who's making it. And if I actually click over here, you can see that this user is a type user, and we're actually able to like grab information out of it, such as, so I can go ahead and show you guys, I can do user and I can see everything. Like I can see some of their name, email address, and everything, but we're mostly worried about the ID or the unique ID for this user. Great. So what we're doing from here is we're going to pull out some information from our request. More specifically, we're going to pull out the salt and passphrase that was generated on the front end. So this information right here. And what we're going to do is first validate to make sure that we have the proper information. If not, we're just going to say, hey, you gave me the wrong data. Try again. And then from there, this is where we're actually going to start working with our database. Now, I didn't mention this earlier, but we're using Prisma. Prisma is an ORM, object relationship mapper, and this just makes it easy to connect to our database. So obviously we have JSON on the front end, and then we are using a SQL database on the back end. So we have to map those two. And if you want to go even deeper, what we're doing is using, it's called Cockroach DB. So that's what we're using to set everything up. And I'll just go ahead and show you what's happening on the back end so you guys can see it for yourselves. But just know what we're doing is, like I said, we're using Prisma to map our front end and back end code over to our SQL database. And that SQL database is just, like I said, a Cockroach DB. And if you want to go even deeper, that's just, it's a Postgres database. But enough about that. Feel free to dig through the code on your own time, but just know it's going to save this data to the back end. And I'll show you it's working in just a second. Then I'll actually go ahead and show you that right now, actually. So what we have is we have a local instance of our database running on this port, localhost 5555. So if we actually go over here and type that in, I just want to show you whenever we pull this up that you'll notice whenever we look at our user encryption table that there's no data here. And that's what we're about to change. So what we're going to do is if we come back over here, you'll notice that what we're trying to do first is check to see if, hey, does this user encryption table have any data where the user ID field matches our current user's ID? If so, what I want to do is check. And just because the way we've set up our code, every user will only have one set of encryption keys. So we just assume, hey, if this is over a length of 0, that means the user already has encryption keys and we just need to update them. But on the off chance, if this is the first time the user is saving their keys with us, we need to create this data. So this is what we're going to do, because right now, if you just remember, our database table is empty. So we're going to have 0 records. And what we're going to do is just say, hey, Prisma DB, we're going to use the user encryption table and we are going to create the data. And all we're going to return back to our front end is going to be a success. Let the user know that, yep, we just saved off all the keys that you just generated. Fantastic. So now that we know what's happening on the back end and with our database, let's come back to the front end. And all we're going to do here is the two things that we initially set out to do. First, check, we already are saving stuff to our database, and now we need to save stuff to local storage. So all we're going to do here is if we get back a status code of 200, meaning everything was a success, we just want to use the local storage to set basically a key value where the key is going to be our OpenAI key and the value is going to be our encrypted key that we talked about earlier. So let's go ahead and start actually saving and using this function here so that we can see everything happening in action. So the first thing we're going to do, I'm going to go ahead and open up local storage so you guys can see what's happening in real time. So the first thing is I'm going to go ahead and hit save, and I would expect something to pop up here, and I would expect a new entry to pop up in this table. So let's go ahead and click save. So it's going to save. We get a little icon saying everything works properly. Now, when I come over here, I can actually see our encrypted OpenAI key. And then finally, whenever I go back to our database and refresh it, I can also see that, yep, we now have a new user encryption row where I can see the user ID. This is the person who signed in. I can see that this is their passphrase and this is their salt. And if you look, this is MIK and then 0WE. If I go back over to application, yep, that looks right. And that looks great too. Great. So now that we know that we're saving everything, what we can do next is actually go ahead and move on to step number 5, where we're going to, we actually merged step 4 and 5, which was, encrypting the keys and saving them. So what we're going to do now is actually move on to step number 6, where we're going to start decrypting this key so that we can eventually start making a request over to OpenAI. So let's go ahead and move on to the next step. So now we're on step number 6, and we're actually going to decrypt and undo everything that we just did when it comes to creating an encrypted version of our OpenAI key. So what I'd like to do is walk you through at a high level what happens when we hit this decrypt button. And then after that, we'll dive into a deep version of what's actually going on behind the scenes when it comes to undoing everything we just did. Okay, so let's hop back over to our code and start going through this. So at a high level, whenever you click the decrypt button, you are actually triggering the handle decrypt function. And what this is going to do is it's going to call the decrypt key, which is going to be using NodeForge to actually do all the decrypting functionality. But as you can see, the main thing that's happening is we need to pass in our encrypted key, our passphrase, and our salt. So like I said, that's what's happening at a high level. And once that gets completed, what we're doing is we're actually just setting that decrypted key to show up right here. So what you would expect to have happen and you'll see this in just a second, whatever I type in here will eventually show up here as well in our decrypted key. So that's the end goal. That's what we're shooting for. So let's go ahead and dive into the low level functionality that's happening. So when we go over to our crypto utils file and look at our decrypt key, what you'll notice is a few things. So when it comes to the first parameter that we're passing in, it says combined, but that's weird. That's not what we said earlier. Well, that's because it's two things. It's actually our encryption key, and then it's also going to be the tag, or really our IV, our initialization vector that we had earlier. It's actually just all getting concatenated into one long string. The next thing that's happening is we're, like I said, passing in our passphrase and salt, because that's what we need to basically undo everything that we did earlier when it came to making this right here. So just to recap, our secret key, that's our encryption key. Our initialization vector, that's the other one. These two got joined together to be our combined first parameter right here. And then our passphrase and salt basically just helps us undo everything that we did earlier to work backwards to get back to our plain text OpenAI key. So enough of that, let's keep diving into what's happening next. So the first thing we're going to do is basically decode using base64 to get back our combined key. Then we're going to pull out our encryption key and then our tag. We're just, like I said, doing some substring manipulation. So once we have our encryption key and our tag, what we're going to do next is start deriving the key and IV, and we're going to do basically undo everything that we just did earlier. So the first thing is we're going to be doing 10,000 iterations, but backwards, to start deciphering our encryption key. So like I said, I'm not going to walk through too much of this part because, like I said, we're basically just setting up everything we did earlier, except with the goal of working backwards to decipher instead of encrypt. Once again, you'll also notice that we're using the same AES encryption algorithm that we were using earlier whenever we were doing the create cipher. So what we're doing here is once we're deciphering, once again, we need to pass in our initialization vector. And then from there, we're going to pass in everything else that's needed to decrypt our encrypted key. That way we can actually pull out our final unencrypted version of our OpenAI key. I know it's a lot. Once again, please just check with ChatGPT to walk you through this because this gets very complicated very quickly. And so I wouldn't get hung up on how it all works. I would just know this is how you go from encrypted to decrypted. That's a mouthful. Let's get back to the application. So what we're going to do, once we have this, I'm going to go ahead and just click it so you guys can see that it's working. So let's go ahead back over here. And now I'm just going to click decrypt. And what I would expect, let's actually make this, we'll do it again so I can say hello world. Fantastic. And I'm actually just going to encrypt it, save it. And now I'm going to decrypt it. So you should see the word hello world down here in the decrypted key. So I'm going to click it. Yep. Fantastic. So that's exactly what I typed up here. Now it's coming out down here. But what I'm going to do next is actually go ahead and paste in an actual OpenAI key so that now that we have our decrypted key, we can actually go off and start making requests to our AI generated endpoint where we're going to make dad jokes that work from OpenAI. And once again, what's happening here, I'm not going to dive into it too deep, but what we're doing is actually making a request to our endpoint. Let me just show you right here. What we're doing is just we're using the OpenAI library, and all we're doing, like I said, this is an OpenAI tutorial, but just know what we're doing is making a request with OpenAI. We're passing in our unencrypted key, and then from there, what you'll notice we're having to set the dangerously allow browser to true, and that's because they normally don't want you passing your users' keys around, because obviously, as you just saw at the beginning of the video when we're going through working with the front end solution only, that you're going to run into a lot of security issues if you're storing your users' keys unencrypted locally. So it's up to us to be very protective about this. And what we're going to do is basically just go off and use some prompt engineering to make a dad joke and return it to the front end. So what we're going to do, I'm going to come back over here to our front end code. I'm going to paste in a real key, and then we're actually going to see it all working in action. So now that we're going to generate our AI dad jokes, I actually wanted to show you this working with a real OpenAI key. So what we're going to do is head over to OpenAI and look at our keys. And we're actually going to make a new one. So we're just going to call this dad jokes. This is just going to be, we're going to go ahead and create our secret key. Obviously, I'm going to delete this after I make this video, but I just want to show you that this works. So we're going to copy it, come back over to our application. I'm going to delete everything and paste in our new OpenAI key. Just go through the process one more time so you guys can see it all working. So I'm going to generate new salt. I'm going to encrypt it. That's going to come up with a super long encryption key. Now we're going to save it. It's going to get saved to our backend database. Now, if I decrypt it, what you'll notice is it's going to be our encryption key that just came from back over here. So you can see this is literally it, but now over here, because it got decrypted. And what we can do now is actually go ahead and generate our jokes. And this will send off our basically decrypted key off to OpenAI, trigger the prompt that we just saw where it makes a silly dad joke and actually just shows it. So let's go ahead and generate it, see what happens. So it generates, takes a few seconds, and then now you can see that we're generating our OpenAI dad joke. So why don't scientists trust atoms? Because they make up everything. And we can just actually keep triggering it. So it keeps working. Why couldn't the bicycle stand up by itself? Because it was too tired. So gotta love some dad jokes. But yeah, that's everything working in a nutshell. We just ran through the 6 tasks that you need to go through in order to protect your users' keys and actually make use of those keys when it comes to working with OpenAI. So that's a wrap for this quick demo of how this works. And once again, please go check out the code so that you can download it and start implementing these steps in your own application. But that's a wrap for this video, guys. I hope you're an expert now at protecting your users' private keys. And don't forget real fast that you can just scroll down in the description to grab the source code for the app that we covered in this project. And you can also book a call with me one-on-one so we can cover whatever issues you may be having. And finally, I do want to mention that if you enjoyed this video, you're definitely going to enjoy some of the other AI related content I have on this channel. We cover full stack tutorials, deep dives into different technologies. So you're definitely going to check out one of the videos that YouTube is recommending somewhere around here. But that's a wrap for this video, guys, and I look forward to seeing you on the next one. See ya.